When creating queries that include multiple tables, it's important to understand how those tables are related in order to get meaningful results. Typically, Access will be able to assist you in building these relationships if they've not been previously defined. But there are occasions when you'll need to create or modify how your tables are joined together. Let's take a look at a couple of examples. First, I'm going to go to Database Tools and take a look at the relationships that we have in this database. We can see that we have relationships between products, orders, customers, states, and our employees here. These are indicated by the black lines between each of these tables. Let's go ahead and delete some of these joins between customers, states, and orders. I'll click here, and then I'll right-click and say Delete. It's going to warn me about my relationships, and I'll just say Yes. Next, I'm going to delete the one between customers and states. Again, I'll just right-click on it and say Delete. Once again, I'll say Yes to permanently delete the selected relationship. Now there are no relationships between the orders table, the customers table, and the states table. Let's see how Access handles this when we create a query. Let's go ahead and close the relationships, and then we'll create a new query in Design View. Let's go ahead and add the customers table, the orders table, and the states table. We'll go ahead and close the Show Table window. Now notice that between the customers table and the orders table, Access generated a new relationship. It saw that we had a customer ID in both tables, here, and that their data types matched, so it assumed that these two tables were related. But if I take a look at the customers table and the states table, you'll notice that there is no relationship between these two. That's because in the customers table, the field is called state, but the related information in the states table is in a field called state abbreviation here. Because the names don't match, Access didn't automatically link those together. Now we can link them together on our own here in the Query Design Grid, just by dragging from state here and dropping on state abbreviation in the states table. That'll create a new join. Or what we can do is close out this query and go establish those relationships back in the relationships map. So I'm going to go ahead and say no to not save any changes here. We'll go to Database Tools, Relationships, and we'll recreate those table relationships. First, I'm going to go from Customer ID here in the Orders table, and I'll drag and drop on Customer ID in the Customers table. It's going to ask me to create a relationship, and I'm going to choose this Enforce Referential Integrity box here and say Create. Next, we're going to do the same thing with State in the Customers table, and drag and drop on top of State abbreviation in the States table. Once again, we'll enforce referential integrity and say Create. Now if we close the relationships and go back and create that same query, Query Design View, we'll go ahead and add our Customers table, our Orders table, and our States table. And we can see if I close the Show Table window that everything is joined properly. Now let's go ahead and take a look at one more example. Let's go ahead and close this query. We're not going to save any changes. And I'm going to run this query over here called Employee Lifetime Sales. I'll double click on it to run it, and we'll see that we have a listing of 19 different employees here. They're listed with their employee ID, their first name, their last name, the number of orders that they are associated with, and the sum total of their suggested retail price of all of those orders. Now, by default, query joins act as what are called inner joins, where data is returned only if there is a match between both tables. This may create a situation where the query does not return all of the expected records. Let's go ahead and take a look at what I mean. If I go into my employees table here, I'll double click on it here, and then I'm going to go over here to the department column. I'll click on the downward pointing arrow, and I'm going to choose the Select All box here to turn off all of the fields. Now, I just want to see the people in the sales department. So I'll scroll down and find Sales and check that on and say OK. That's going to filter my employees data table to just the salespeople. We can see that I have a total of 21 people here. Now, if I take a look at my employee lifetime sales, though, I can see that I'm only returning 19 people. So I'm missing 2 of my salespeople from the employee lifetime sales query. Let's go ahead and close the employees table here. I'll select it and press close. I don't need to save any changes here. And let's go into Design View for this particular lifetime sales query. I'll right click and say Design View. Now the problem is that I have 2 employees in this particular database that aren't associated with any orders. And by default, Access is only showing me information where I have employees with associated records in the orders table. If I double click on the join line between those, we can see that. We can see that we're currently set to this option number 1, only include rows where the join fields from both tables are equal. That's the situation we're in right now, where we have employees that have sales over here in the orders table. If the employee doesn't have any sales in the order table, then they don't appear in the query record set. Now I have 2 additional options here. Option number 2 says include all records from the employees table and only those records from the orders where the join fields are equal. That sounds like what we're looking for, so I'm going to choose option 2 here. Just for reference though, the third option says include all records from the orders table and only those records from employees where the join fields are equal. Now, because in our database we're enforcing referential integrity, we shouldn't have any situation where we have an order that isn't associated with an employee. So option number 3 probably doesn't apply here. So I'm just going to leave it on option number 2 to include all records from the employees table and only the records from the orders table where they're equal. Let's go ahead and say OK, and we'll try and run this query. Now Access is going to give me a message here saying that the SQL statement could not be executed because it contains ambiguous outer joins. That's because we're trying to join between the employees table and the orders table, and then the orders table to the products table. In order to see all of the employees, and for the employees that have those orders, we need to actually create 2 queries, or in fact, create a query built off of this query. Let's go ahead and say OK, and I'll show you what I mean. I'm going to come back in here, I'll double click on that join line again, and I'll change it back to option number 1 and say OK. Now as a reference, if I run this query, we're only getting the 19 employees that actually have sales. If I wanted to see all 21 employees, we'll need to build a new query. So let's go ahead and close this out. Not going to save any changes. And we'll create a new query in Design View. Here I'm going to use the employees table. I'll double click on it to add, and I'm also going to pull in that query. I can switch this tab over to the Queries tab in the Show Table window, and double click on the Employee Lifetime Sales query to add it to my query design grid. Let's go ahead and say close. Now we can see that Access already established a relationship between this employees table and the Employee Lifetime Sales query because both of them included this employee ID field, and it can tell by the data types that they are related. So now what I can do is add fields from both of these into the query design grid down below. Let's go ahead and expand these open a little. And I'll move this one over and expand it down. Here I'm going to choose from the employees table to show the employee ID, the first name, and the last name. And then from the lifetime sales table, I'm going to show the count of order ID and the sum of suggested retail price. Now if I run it, we'll see what the results are. We're getting the exact same 19 records that we got previously. Let's go back into Design View. Once again, that's because we're only seeing employees that have records from the employees lifetime sales query. To adjust that, we'll just double click on the line and choose option number 2 to include all records from the employees table and only those records from the employee lifetime sales query where the join fields are equal. We'll go ahead and say OK and try running it again. Now we can see that we have down here at the bottom 741 records. These are all of our employees. And if I scroll through, we'll find the ones that are in the sales department have the additional records of count of order and sum of suggested retail price. Now what I want to do is filter these to just the sales team. So once again, I'll go into Design View. I'll add in department, and then underneath department, way over here on the right, I'm going to add a criteria that the department is equal to sales. Now I can go ahead and run it and see the results. Now I see at the bottom that I have 21 records. These are my 21 salespeople. For the ones that have orders, then I can get the count of how many orders they have and the sum of suggested retail price. And for those 2 employees down here at the bottom that don't have any sales, we can see that those values are blank. So understanding how your data tables relate to one another is a critical component to creating well-structured queries that give meaningful results.